Welcome to the F+L podcast. My name is Vicky Denton, and I'm your host. Our guest today is Joseph Starr. Joseph is currently Business Development Manager at ExxonMobil Product Solutions. He's based in London. Joseph joined ExxonMobil in 2015 after obtaining his degree in mechanical engineering. He has held a number of roles throughout the lubricant and fluid value chain at ExxonMobil, ranging from leading a technical used oil analysis program for two-stroke marine engines to managing the Mobil Guard and Mobil Jet brands for ExxonMobil's finished lubricants business. He's currently responsible for sales and marketing for specialty products within the company. So, without much ado, let's start the conversation with Joseph. Joseph, we gave our audience some background, your professional background. Maybe you can tell us a little bit about yourself. What do you like to do besides lubricants and fluids?
Yep, sure. So thanks, Vicky. Yeah, looking forward to, talking through immersion cooling and kind of the data center fluids today. As you mentioned, I'm based in London, so from the UK, originally, from a free time point of view. So I'm pretty big into sports. Here in the UK, football or soccer, I guess, depending upon the audience, is kind of the big sport that we follow. Play that kind of fairly regularly, and into golf as well. Those outdoor activities keep me busy when the weather allows here in the UK. That's I guess a bit about myself, and then, as you mentioned, from an ExxonMobil point of view, yeah, I've had a number of different roles across engineering, sales, marketing. I guess kind of all within what we call at ExxonMobil the specialty products business. So kind of looking at lubricants, fluids on a global and on a European basis.
So you're sitting in an area, actually, I think, which would be considered a hub for data centers, right? Germany is a big data center in Europe. Tell us, what are data centers and why is it such a hot topic right now?
Yeah, and so I guess from a kind of what is a data center point of view, think of kind of a whole row of servers and a whole row of kind of electronics that store anything from commercial data to kind of personal data, and kind of you have some of the big kind of cloud computing providers like Amazon Web Services and others that kind of rent out some of this computing space and some of this data space to third party customers. Why is it kind of booming right now? I think you just need to look around. You look at kind of the rise of AI. You have ChatGPT and kind of all of those other AI tools that are kind of propagating, which drives the need for processing power and drives the need for that data storage. In addition to kind of pretty much everything in our everyday lives now is moving from kind of physical through to virtual or through to the cloud-based systems, and you need to have somewhere to store and to manage and to process all of that data. So if you think of, I guess, the scale of data centers in the world right now, the IEA reported that in 2021, kind of data center electricity use was around 2% of global electricity use. So it's getting kind of bigger and bigger, and the expectation is that will only continue. And if you think through kind of the hubs or kind of the locations as to kind of where data centers are located, obviously you want to try and have your data center as kind of as cold as possible. So there are kind of certain locations where your ambient temperature may be lower, where you want to try and have those data centers. And I guess even kind of going back kind of a few years, kind of Microsoft and Google and others have actually experimented with kind of putting data centers in a kind of in water, so in the bay in San Francisco, as an example. Lots of, I guess, kind of AI and kind of the need for that kind of cloud computing space that's really driving the growth behind the data center space.
To put it simply, I mean, I've seen pictures, but I've never been inside one. Data centers is really a big warehouse full of um, huge servers, right?
Yeah, yeah. So think of like a huge, kind of a huge space that has kind of cabinets or kind of vertical racks. You have quite often that have a load of servers, or a load of kind of GPUs or CPUs kind of running in tandem, or running in parallel to store and to manage all of that data.
So apparently, I was reading an article recently about data centers in Berlin. And apparently, it's not a simple thing to find a location. You're really looking at multiple aspects when you build a data center. And I guess the question is, how important is that the location for a data center? And then what is the role of fluid? This is like an emerging area for our industry. Why is it just emerging now? What was the technology that was being used before immersion fluids seem
Yeah.
to be now taking over?
Yeah, sure. And so I guess from kind of from a liquid cooling point of view, which doesn't just include kind of full immersion where you put all of the servers and the equipment inside the fluid, there are other technologies as well. But kind of liquid cooling kind of is roughly present in about 8% of data centers today. The expectation is that will kind of grow to about 18% by 2032. And I guess the reasons behind that are you take a look at kind of the processing power that is present. So to keep up with the needs from an efficiency point of view, you need to run the equipment and run the details kind of hotter and hotter. You push kind of more power through. The chips themselves are getting more and more powerful, and so you have more heat to try to dissipate within the same area. So I guess the gold standard or kind of the key metric when you look at it from a data center point of view is your power use effectiveness. So that's essentially a case of all of your kilowatts or your power going into your data center. What is the ratio that goes to powering the chips and kind of powering the components themselves versus all of the rest of kind of the ancillary products? And there has been a lot of progress made and a lot of kind of incremental gains to drop that down as you kind of look forward. But one of the biggest kind of jumps I guess the industry is looking towards is really that change from air cooling to liquid cooling on a wide scale basis. So you think about it from a physics or from a chemistry standpoint, when you switch from air through to some kind of a liquid, you get probably a 30% cooling benefit through making that transition. So that is kind of one kind of piece that's really looking to, I guess, kind of enable the continued growth of data centers. And just as you mentioned, from a location point of view, so can't I guess speak to at length on that point, but the key I guess piece that we hear is all around making sure that depending upon the location, you have the right access to power as needed, and you need to have the right kind of voltage and ampage coming in, and also the right, obviously, kind of location and cost from that point of view. So, if I kind of draw parallels to, I guess, a similar-ish market in the crypto mining space, where essentially these guys are running similar setups, you'll find that there are those locations are typically where you have an abundance of cheap or extra power that can be utilized in the system. So kind of down in the Gulf in the US, and then over in the over towards the Middle East, kind of another kind of big location. So that's kind of really, I guess, the background to that point of view. And I guess liquid cooling or different variations of liquid cooling is nothing new. So kind of the portion of the market that we're entering at ExxonMobil, it's what we call single phase immersion cooling. So the liquid doesn't change from liquid, whereas an alternative form is two phase immersion cooling, which has been used for some time. And so that's where the liquid actually changes through to gas and then back through to liquid in a closed system. But there are concerns around some of the fluids that are used in that area from a PFAS point of view, which is looking at kind of forever chemicals, and then also a global warming potential perspective. So kind of some of the recent regulations in that space or driving people to look at alternative forms of liquid cooling, and kind of the full immersion piece is one that is definitely growing and having more and more momentum moving forward.
Let me pick up on something you said earlier, Joseph, if I may backtrack.
Sure.
You mentioned 8% of the market only, and then growing to 18%. What kind of volume is 8% versus 18%? It doesn't look like a big jump, but um, it's in a market like lubricants, where in the West, typically 1 to 2% is pretty significant. Well, 10% is pretty big, isn't it?
Yes, I mean 10% in kind of 10 years is pretty significant, and I guess that's obviously kind of the overall basis from a data center point of view. But you also need to factor in kind of the ongoing growth of kind of data centers in general from from now out to 2032. And so we were recently at the Open Compute project in San Jose in California, and there were a lot of kind of presentations and forecasts, and I think we heard kind of different kind of viewpoints in terms of how big is this market going to be. So the expectation that was kind of shared publicly at that event is that the whole kind of immersion or liquid cooling value chain could be worth anywhere from $10 billion to $20 billion. And obviously that isn't just obviously the fluid, that's kind of everything from the tank manufacturers through to kind of other elements, heat pumps and circulation pieces that go into making the system as a whole. So a lot of potential growth that we see and the industry kind of really sees here. I mean, to your point on it, kind of 8%, I guess, is somewhat low right now, and we expect that to jump to 18% by 2032. And I guess a lot of that is really driven by when you look at kind of building or kind of commissioning a data center, and then when you're looking at immersion cooling as a potential option or a potential piece to kind of optimize your operation. There are a lot of, I guess, changes that kind of you would need to think through from an operations standpoint or a logistics standpoint when going from air cooled through to immersion. So I think the expectation is really that kind of immersion is going to be a go forward solution rather than potentially kind of a retrofit point of view. Is kind of you look back, because you need to take a look at your entire kind of infrastructure and then kind of look at your floor space, and all of those elements need to really be considered.
So how come air cooling was the preferred technology in the early years of data centers? Was it cheaper? Was it technically more possible at the time? We didn't have the fluid properties that they needed, or it was too expensive?
So I mean, I guess you take a look at the way kind of computing has been managed and kind of cooled over the past 20, 30, 40 years, and kind of, I guess, air has always been the first step. So the real piece has been that, I guess, the system and the infrastructure has not been pushed enough to warrant kind of looking at alternative solutions from there. Whereas now, yeah, when you're looking at kind of when you're trying to reduce your power usage effectiveness as close to one as possible, kind of pretty much all of those incremental pieces have been kind of looked at and kind of optimized through already. So that's where you need to look at a step change in how you manage that one. And again, I mean, air cooling isn't the only cooling system that's been around. Again, kind of there are kind of cold plate, direct to chip pieces, and the kind of the two-phase kind of cooling methods that are there already. Whereas again, I guess through a need of different regulations and through a need of different overall performance characteristics, that is why immersion cooling with a dielectric fluid is now on the table.
So Joseph, you mentioned single phase and dual phase. The 30% efficiency increase, where would you get that from? The single phase or the dual phase immersion cooling?
So the 30% efficiency kind of benefit is really kind of when we've taken a look at from air cooling through to single phase. That's, I guess, kind of the statistic and kind of the information that ourselves and other kind of folks in the value chain have gathered. Two phase is efficient, and is probably likely to be more efficient, given that you have that phase change that acts as a really good cooling mechanism.
So you touch a little bit on technology. Let's talk about the
Yep.
technology available. You mentioned synthetics. So basically, in this segment, you can only use a synthetic base oil. I mean, there can't be any other player. So you're talking about polyalpha olefin. You're talking about esters. What other base fluids would PAG also qualify, or it doesn't have the right properties for the requirements of in this specific application?
Yeah, and so I guess again for full immersion, one of the key fluid characteristics that you're looking for is obviously the dielectric property. Given the fluid is kind of circulating around, it's going through all of the components. So the vast majority of hydrocarbon based fluids have that property inherently. And from a kind of an overall landscape point of view, there are kind of different options available. So if I think through kind of the ExxonMobil portfolio that we launched a couple of weeks ago, the majority of our fluids are kind of based upon, yeah, as you mentioned, kind of synthetic fluids, which are in our case polyalpha olefins. So that's a very stable molecule, and kind of provides a relatively high flash point, depending upon the grade. So which is a key performance characteristic from, obviously, clearly from a safety point of view, that you need to be aware of. But then also within our portfolio, we have other kind of elements, or other fluids that are based on different chemistries and different hydrocarbon bases. And again, similar, if you look at the other kind of potential single phase immersion fluids out there, the vast majority are really kind of polyalpha olefin based, or synthetic ester based, because again, they are the ones that give you that dielectric benefit and give you the high flash point. And I think, in addition to, just to mention on there, is that kind of when you're looking at kind of the fluid selection, another key characteristic is really your fluid viscosity. So depending upon how you run your system, so there may be heat pumps or kind of heat exchangers in there. Clearly, the lower the viscosity fluid, the better, because you require less energy to circulate that fluid around and to kind of manage it through the system. So that's why, from ExxonMobil's standpoint, we launched a fairly broad portfolio. We have kind of 6 fluids out there, which again, we know our fluids, we know kind of how they perform. We have a history of kind of innovation in that space, but the industry is emerging so rapidly that kind of regulations and standards and expectations continue to change. So that's why kind of the thought from the team on our side was, let's try and have as kind of broad a portfolio as possible, and then ultimately we'll let kind of the industry dictate and decide which one of the kind of the combinations kind of really makes sense for their different operation.
Joseph, in terms of the composition of the finished product, the immersion fluid, is it a pure base oil product, or are there additives added to the finished formulation?
Yeah, so I guess from our standpoint, I can't get into the details. So the formulation is proprietary, but there are characteristics in there that you need to think through from a base oil standpoint, and potentially from an additive standpoint as well. So if you think about kind of the system itself, there's probably over kind of 200 different components in there. So one of the key pieces you need to think through is your material compatibility. So from switches to cables and all of those different elements that are there, which is kind of primarily a base oil property, but also you need to think through kind of the lifespan of the fluid as well. When you can either kind of get some of that performance through looking at kind of, I guess it's a combination of potentially of what additives are included and kind of what your base oil technology is, to make sure you can lengthen the lifespan of the fluid beyond the overhaul period of the equipment.
What is the expected lifespan of these immersion fluids? How often do you have to replace them? Is it a complete replacement or a top up?
Yeah, so because it's single phase, there's obviously there should be no loss, or no kind of evaporation of the fluid itself. So the expectation is that there should really be no top up of the fluid, once it's kind of there in the tank and with the components. And again, for the majority of kind of the ExxonMobil portfolio, we expect that the fluid should last 10 years. It is, again, kind of very, very stable from a molecule point of view. So we believe that the fluid should outlast kind of the lifespan of even some of the equipment in kind of the servers in the data centers themselves, which typically kind of can get kind of overhauled or changed or switched out between kind of 5 to 7 years.
So when you do your fluid change 10 years later, what do you do with the spent fluid? Do you regenerate it?
Yeah, and so from a circularity point of view, so there are no kind of confirmed circularity programs yet, as I guess kind of some of the current immersion cooling systems have yet to reach that kind of that overhaul and that lifespan. But from a path forward point of view, the expectation, the hope is that we can take that fluid, similar if you will to kind of the re-refined base oil approach on the lubricant side. You can take that fluid and then give it another lifespan. So again, there will have to be differences compared to the lubricant side, given you're dealing with different contaminants or potentially different kind of materials that leach into the fluid. But yeah, the circularity piece is again one that the industry needs to consider, and one that we'll consider moving forward as well.
When you design a fluid, Joseph, how do you measure the potential lifespan of the fluid?
So again, it's trying to work out what's the limiting factor. So is it going to be the fluid degradation itself? Is it going to be kind of some of the material leaching and so on that happens, or just what is that kind of limit that you need to be mindful of? And so we've done a lot of different kind of I guess kind of simulations and a lot of different kind of forecasts from that point of view, and we have a lot of experience again in the chemistries that we're putting forward in this space.
And then during the 10 years, of course, you haven't reached 10 years, but um, how would you check on the quality of the fluid if it still meets the requirements of the chips or the equipment? Do you have to open it up every year, check on the properties? How do you do that?
Yeah, so again, and I guess this is where kind of the industry standards and industry expectation comes in, and that there is no, I guess, kind of formal testing program or kind of formal piece that's kind of conducted right now. But again, and our expectation is that there should really be no issue unless you get some kind of an external contaminant in there. But again, if you take parallels to the lubricant industry, where kind of used on analysis is a fairly regular and kind of typical occurrence, I wouldn't be surprised if there's kind of elements of that space that come into the immersion cooling point of view. Again, because you're dealing with thousands of dollars of hardware in there that you want to again make sure is protected, is fine, and your system is operating as it needs to be. And again, I think that's where when you look at kind of an immersion fluid partner, you need to kind of go through and consider who has expertise and who has kind of credibility through in that area. So again, if I take some kind of knowledge and experience from my lubricant side, we have or ExxonMobil has the Mobil lubricant analysis program, where there are kind of global labs across the world that deal with millions of lubricant samples coming through every year. So I could definitely see a world where there's a similar need for kind of certain testing of parameters that needs to occur on the fluid itself, really as a kind of peace of mind and confidence check that everything is working as needed.
So potentially could be a separate service. It's not embedded in the price of the immersion fluid.
Potentially, yeah.
When you test fluids, at least in the automotive space, you have industry test methods and third-party labs. Are all the tests for immersion fluids right now proprietary, or are there industry test methods?
So I guess some of the tests that are conducted, obviously the industry looks to leverage kind of the appropriate ASTM standards. So for Flashpoint, for example, we look to follow the ASTM standard from that point of view. But I guess your point, Vicky, from like an approval kind of point of view, if I kind of compare it to OEM approvals on the
Yes.
lubricant space. So again, because this is such an evolving space, there aren't really a set of industry standards out there today. So that is what the likes of Open Compute Project or some of the other manufacturers and kind of participants in the value chain are looking to kind of complete and I guess kind of mandate, so that there is a level of consistency both from a performance and a quality standpoint that is set out there. And again, I think the key piece there is on obviously from a safety point of view, making sure the fluid is safe, both from a use point of view and then from a handling point of view. But I guess the expectation is that those standards should begin to kind of work their way through the industry in the coming months and years. And I guess again, similar to the automotive or the OEM space, they'll continue to evolve as kind of the industry looks at it. And I think there's you mentioned, I guess, the typical kind of lubricant space. I think there's a lot of similarities here from what I see in my prior experience and kind of what I see here, in that it's a very complicated value chain, to use an ExxonMobil expression, where you have kind of folks from looking like Intel and those manufacturers who manufacture the chips themselves, all the way down to kind of the end users, and then probably about 5 to 10 individuals or groups of companies in the middle that either manufacture components for the system or kind of have an approval or a stake or kind of potentially warranty concerns in there. And so I guess everybody is looking at their own individual piece right now. And I think, again, the hope and the expectation is that as we've seen a shift from kind of OEMs and automotive engine manufacturers on the lubricant side, where there was a mindset shift from considering the lubricant just as a component to actually kind of optimizing the whole system, and considering all pieces in the chain. I think, yeah, my hope is that that will happen again in the immersion cooling space. So we will hopefully get, yeah, kind of not only tanks that are obviously specifically there to manage the immersion cooling systems, but also when you look at kind of servers and other pieces that are there to, I guess, really work symbiotically with everything, rather than kind of taking pieces from here and there and then kind of plugging them in.
Yeah, you did talk a little bit earlier about some of the challenges, but maybe you can be a little bit more specific on them. So one of the things you mentioned is flashpoint. That's very obvious. What other challenges, particular challenges, when you create an immersion fluid? You said you have quite a broad range, so I assume the range varies in terms of viscosity and maybe other features. What are the key technical challenges you're trying to address by offering such a broad range? So I assume each one of this apply to a certain specific requirement, maybe of an OEM. Maybe you can tell us a little bit about it.
Yeah, sure. So I guess from a general technical challenge point of view, so I mentioned kind of the material compatibility being one of, again, of all of the components that are there through in the system. And then again, if you are kind of looking at kind of developing a data center from new, or kind of retrofitting a data center, it's really all kind of how do you manage and how do you upkeep that piece moving forward. So one of the key challenges is kind of thinking through maintenance of the equipment and kind of maintenance of the servers and so on. And even just think about it kind of visually, in the kind of, you had a lot of these racks right now that are kind of horizontal, so you can pull them out, kind of change the servers, fix the kind of processing units as needed, and then be able to slot that through back in. Whereas if your rack is kind of fully immersed in a tank, you need to make sure you have space and so on to lift the rack, put it down, do what you need to do, and then kind of put it back in. But I guess that's kind of a general kind of immersion cooling challenge to overcome. From a fluid point of view, so kind of what are we trying to achieve by launching kind of the broad portfolio? Again, it's the fact that we are hearing so many different needs and different requirements across the industry and across different regions as well. So there are kind of certain different regulations, kind of location by location. So there are some locations where kind of a higher flash point is kind of mandated from a government standpoint, and there are other locations where that mandate is not in place. So that's where, if you take a look at the portfolio that we have, the majority of fluids kind of range from different viscosity grades and also different flash points. So I guess they are kind of the two key parameters that we have variation on, which speaks to an extent to the efficiency piece that I mentioned earlier. So again, our kind of thought and expectation is again, we'll have all of kind of the 6 products that we have today, but that isn't going to be, I guess, the end of our development or kind of the end of our focus in this space. This is very much kind of generation 1, if you will, of kind of the immersion fluids that we have, and we will be continually be taking to take a look at kind of what are the chemistries do we have, kind of what other performance characteristics do we see, and kind of really looking at kind of what experience do we get through working with a lot of folks in this value chain to see what they need and being able to adjust our offer for them moving forward.
So you're in a very interesting space. a developing space. I mean, when you look at this field compared to traditional fields, like you worked on two-stroke, um, and even you look at ice today, it's
Yeah.
going to be a dinosaur in 20 years, right? Uh, right now, people are only talking about low viscosity. Fuel efficiency, of course, is the driver for that. What do you think would be the driver for immersion fluids in the future? Let's talk about maybe how do you see Gen 2 and Gen 3, or is that too difficult even to imagine today?
Yeah, and I guess I mean, when I first joined ExxonMobil and was working on, I guess, kind of the largely Group One based sort of two-stroke marine diesel engine oils, I never thought that I would be going to Silicon Valley in California and kind of looking at, I guess, as you mentioned, something that wasn't even there when I joined the company. So it's definitely amazing to see kind of the transition and the scope as to how some of these different chemistries can be used, or some of the similar chemistries can be used across different applications. If you, I guess, kind of ask me to kind of crystal ball and kind of look ahead as what does Gen 2 or what does Gen 3 look at, again, I think kind of all bets are off. I mean, it really depends in terms of how the industry goes and where the industry progresses. I think there's definitely an expectation or a realization that kind of one form of immersion cooling or one form of liquid cooling won't fit all. So depending upon the data center's needs, location, scale, and so on, there are different options available. Which I think kind of it's really going to be a cocktail of options moving forward. Clearly, from an immersion fluid point of view, you need to retain your dielectric properties, and I think again it's really on trying to understand further how do I guess kind of the two separate industries, if you will, from like a heritage kind of fluids and chemicals point of view, match up with kind of the IT and kind of computing industry, and how do they kind of work together and progress forward. And I know from our standpoint, we're already in discussions with kind of a lot of folks kind of throughout that value chain piece that I mentioned. There's definitely a hunger for collaboration, which again is great to see, because the realization that this is going to have to continue to kind of meet the needs of society and kind of meet the needs from a data center point of view is clear. And then there are also kind of regulations which are continuing to drive the need for immersion cooling and those pieces from a data center point of view. So you mentioned Germany, I guess, as kind of one hub. And kind of there's certain regulations that are kind of becoming present in Germany and other locations that kind of mandate a certain efficiency of the data center, or actually kind of also make sure that the data center and similar facilities are a net zero water facility, which again is kind of another kind of benefit of what you can look at from immersion, given you can reduce the water use from that point of view. And I guess that the most interesting piece from my point of view is really that there are actually kind of folks out there who are turning, I guess, what is seen as a waste product, which is the heat from the data centers, into something useful. So if I think through here in the UK, it's a pretty dark and miserable cold day today. So we like to have all of the heat we can get. And there's an example down on the south coast in the UK of where kind of the heat from a data center has been kind of captured and transported and actually used to heat a public swimming pool. So that kind of ingenuity and innovation is exciting to see, and hope it continues.
Yeah, actually, that's a very interesting point. The article I was talking about mentioned about reusing heat waste. And apparently, one of the real problems with this is that the heat waste facility has to be located near the data center, and there's not always a heat waste facility near the data center. So transporting it or a location further away doesn't really make that feasible. So it seems like um, in addition to that, you need a lot of power for these data centers, and apparently a lot of lo- locations, including Berlin, really have a problem with data centers eating up all the capacity from the grid. Or I guess if they do have their own power generation facility, I don't know how common that is for data centers to generate their own power. Their consumption is so huge. Their power consumption is so huge. It eats up the, whatever um, maybe a location is generating for the community. So those are real big issues, aren't they? That could really limit the possibility of having a lot of data centers in one location.
Yeah, I mean, I think as I mentioned before, the key, I guess, kind of decision criteria or a kind of key limiting factor from a data center location point of view is access to power, and it's access to the right type of power. And if you kind of take a look at, I guess, kind of the energy use again of data centers, that's increased in total by about 60% compared to 2015. And so again, as data centers continue to be required, then yeah, those folks who are kind of commissioning them and kind of locating them are going to have to think through all of those elements, from location, access, potentially can I reuse some of that heat, and kind of where can I put it, and where do I go through and kind of optimize that full system. But again, when you're looking at how to, I guess, kind of mitigate some of that power use, then clearly kind of the more efficient your system can run, the better you can be. And I think we've seen some immersion cooling systems run down at kind of 1.03, 1.04 on the power use effectiveness level, which is obviously close to kind of where you can get to from, or close to your objective of getting to as close to one as possible.
Yeah, Joseph, is it possible that one of the limitations of this sector for our industry would be not having enough capacity to supply such a huge market? Like, do we have enough PAO capacity in the world? Do we have enough ester production in the world? I keep hearing new capacities being put online, especially for synthetic esters. For PAO, obviously, those are huge facilities. So ExxonMobil keeps on adding capacity um, in Texas, for example. But you have the requirement from, for example, the wind power sector. You have the requirement from the automotive sector. You have the requirement from immersion fluids. Um, could could the demand be limited by the capacity you can put on the ground right now? Because it's not really that easy to put up new capacity, right? I mean, maybe every 5 years would be the maximum, to debottleneck a facility.
Yeah, and so I mean, from ExxonMobil's standpoint, I mean, our kind of position has always been that we don't want to starve or kind of, I guess, kind of limit the growth or kind of limit the piece of any market. So we're committed to capacity increases as needed across the network. And I mean, again, there are a lot of kind of I guess crossovers from a molecule and from a fluid point of view into kind of the traditional lubricant space, and then through into the immersion cooling space. And I guess from the figures that we've seen, I mean, the immersion cooling space is going to be material if kind of the forecasts are true, but I don't think it's going to be any concern from a fluid availability standpoint. That there should be enough flex in the overall system, and kind of enough, I guess, kind of different offers and different molecules that make sense across kind of both different industries, that that both should be able to manage and kind of get through what they need. Again, particularly that for the immersion cooling space, you want something kind of lower viscosity. So you're not competing with, I guess, every industry in the traditional lubricant space. It's only a couple.
So, in other words, the message you have is that you're not capacity constrained. So potential growth is not really an issue for this sector. Is
Yeah,
that correct?
yeah. I mean, that there are, I think, when you look at again kind of the forecast and kind of the expectation out to 2030 and 2032, there are a whole load of I guess kind of other logistics concerns or kind of other pieces in the immersion cooling value chain that are going to have to keep pace with that need and that demand. And I don't see kind of fluid availability being one of those.
Yeah, this is really an exciting space, and we hope we can follow what's going on in this area. Um, Definitely very interested, in seeing how our industry can contribute to this important sector. Obviously, all of us use um, cloud computing one way or the
Yep.
other. Uh, you know, iCloud or Google or Amazon. And this is not the future. We're in the future, isn't it?
Yeah. I mean, as you say, I think we take a lot of the I guess kind of the pieces at our fingertips for granted, and we don't kind of fully understand where the electrons come from and kind of where all that data through is transmitted. So yeah, the demand is or the demand in the kind of society's pull for the information and the computing power that these data centers need to support is not gonna slow down anytime soon. So yeah, we need to continue to look at kind of innovative solutions, kind of collaboration throughout the industry to make sure we can kind of keep pace with society's demands and make sure we do it in an efficient and an effective manner moving forward.
Yes. Any last words, Joseph, before we close?
No, I think yeah, thanks for the opportunity. It was yeah, great to I guess talk through where we see the market going, and yeah, as you say, kind of a very exciting and kind of different space where yeah, here at ExxonMobil we're excited about the future, and yeah, looking forward to kind of progressing our offer in this space and enabling yeah, kind of more and more efficient data centers moving forward. So yeah, thanks for the time.
Well, thank you so much for joining us today. We really appreciate it. And
Thanks.
with that, we'd like to again thank Joseph and ExxonMobil for joining us today, and we hope to hear from them again in the future. Have a great day.